Hello, I am Sunita. Welcome to my class. Here I am going to discuss GPSTR science topics according to the syllabus. Here the topic is magnetism, very important topic. What is meant by magnetism, then properties of a magnet. Then here I am going to discuss two important laws, that is Savret's law and Ampere circuit laws, and also their applications. Let us discuss what is meant by magnetism. Magnetism is the phenomenon due to which certain substance attract piece of steel, iron, nickel, etc. Here magnetism is nothing but a magnet. It will attract a substance like piece of steel, then iron, nickel, etc. This phenomenon we will call it as a magnetism. Then magnets are used in many devices like electric bulb, telephone, radio, loudspeaker, motors, fans, screwdrivers, lifting heavy iron loads, superfast trains. Especially in foreign countries we will use magnet. Then even refrigerator also we will use a magnet. Then magnetite is the world first magnet. You have to remember this one. Magnetite is the world first magnet. This is also called as a natural magnet. Though magnet occurs naturally, almost all the magnets they will occur naturally in the earth crust. We can also impart magnetic property on a substance. It would be an artificial magnet in that case. You can impart, otherwise you can induce some magnetic property to a particular substance. That magnet we will call it as a artificial magnet, because artificial magnet is man-made magnet. Let us discuss the properties of a magnet. First property, magnets attract objects made up of iron, nickel, cobalt, almost all the metals it will be attracted by the magnets. Second property, magnets have two poles, the north pole and the south pole. Magnets, it has two poles, one is north pole, another one is south pole. Third property, poles always exist in pairs, they cannot be separated. Already you know the magnet, it has two poles, north pole, south pole, and these poles you can't be separated. If you cut the magnet into even very small piece also, even that small piece also it has two poles, one is north poles and also another one is south pole. Therefore you can't separate the poles. Fourth property of a magnet, opposite poles of two magnets attract each other. Opposite poles means south pole, north pole. Opposite poles, they will be attracted by each other. Next property, like poles of two magnets repulse each other. Like poles means north pole, then south pole of a magnet, they will be repel each other. Then next property, if a magnet is suspended freely by a thread, it aligns itself in the north-south direction. If you suspend a magnet freely, then it will come in rest in north-south direction. Therefore, the magnet always it will align in north-south direction. These are the few important properties of a magnet. Let us study in detail Savret law. Here, when a current is carrying in a conductor, then it will produce a magnetic field around it. This blue color wire, it is a wire carrying current. Then if it is wire is carrying current, and it will produce a magnetic field around it. How you know that one? Keep a magnetic compass near to the wire carrying current. Then that magnetic compass, it will show deflection. It will indicate the current carrying conductor, it will generate a magnetic field. Here, according to this law, consider a point P near to the conductor, otherwise conducting wire. Then here, how much magnetic field it will experience by that point, how much magnetic field it will experience on the point P, how we have to calculate. But if you consider full length of the conducting wire, it is impossible to calculate the effect of magnetic field on the point P. For our convenient, we have to consider the small portion of the length, then that is indicated by current element dl. Then here this point, this direction, it will show the direction of the current. This arrow mark, it will show the direction of the current. And the point P to the conducting wire, if you draw a line, this it will indicate the radius vector. This all are vector because they will give even magnitude also, and they will show even direction also. dB, this is the symbol to represent a magnetic field, dB, because here d it will indicate we are considering only the small portion, dl it will indicate only small portion we are considering here. Then this is the theta, angle between current element and position vector. This is the angle, this is the conducting wire. Then this theta, it will indicate the angle between these two lines. Then here you have to calculate the magnetic field, how much magnetic field it will experience on the point P, because the wire is carrying a current, it will produce a magnetic field. Then here Biot-Savart law just mathematically states that the intensity of magnetic field at a point, it will show how much intensity of magnetic field at a particular point P. This is the direction of magnetic field at a point. This arrow mark, it will show the direction of magnetic field at a point P. Then according to the Biot-Savart law, magnetic field dB due to a current element ideal at a point P situated at a distance r from the current element ideal is, here already I told, ideal it will represent a small portion of the length of the conducting wire, and P is the point that it will experience the magnetic field. Then theta is the angle between the current element and the position vector, and R is the P situated at a distance r from the current element dl, or is the radius. Then here this arrow mark, it will show the direction of a magnetic field. Then this how much magnetic field it will experience on the point P, it is given by the formula dB, it will be equal to mu naught divided by 4 pi I dl into sine theta divided by r square. According to this equation, here according to Biot-Savart law, magnetic field, how much magnetic field it will produce, otherwise it will experience on the point P, it is directly proportional to the current element ideal. It is directly proportional to the current element ideal, and directly proportional to the sine of the angle, and also it is directly proportional to the sine of the angle, and angle theta between the current element and r, and inversely proportional to the square of the distance r between the current element and the point P. Here according to this Biot-Savart law, how much magnetic field it will experience on the point P produced by a current carrying conductor in a wire, it will be directly proportional to the current element dl. It will be directly proportional to this length of a small length of the wire, and is directly proportional to the sine of the angle theta. That theta is made between the current element and also distance from current carrying conductor to that point, this the distance r. Then it will be inversely proportional to the distance r between the current element and the point P. Then here how much magnetic field it will be experienced on the point, it will be directly proportional to the current element length of the wire, and also it is directly proportional to the sine theta, but it's inversely proportional to the square of the distance between the point and the conducting wire. These 2 points, very points you have to remember. Then dB, it will be equal to mu naught divided by 4 pi into I dl into sine theta divided by r square. Here proportionality constant is mu naught divided by 4 pi. Its value is 10 to the power of minus 7. Then here mu is the permeability of free space or vacuum. This is the constant you have to remember. According to Biot-Savart law, you are finding the magnetic field experienced by the point P because of this current carrying conductor. This one you have to remember. Next, the direction of magnetic field is always in a plane perpendicular to the line of element and position vector. It is given by the right hand thumb rule. This is the right hand thumb rule. According to this rule, the thumb points to the direction of the conventional current, and the other fingers, if you fold the fingers, other fingers, it will show the direction of the magnetic field. Let us see this picture. This is the direction of the current. Then if you hold the current carrying conductor with your right hand, then the thumb, it will indicate the direction of the current. Then this fingers, if you fold the fingers, this, it will show the direction of a magnetic field. Here this, it will show the direction of magnetic field. It will outside of the conductor. It will point towards outside of the conductor. Next one is Ampere's circuit law. This law is useful for to find out the magnetic field. This is the alternative method to find out the magnetic field B. Here the magnetic field, it is indicated by B. The magnetic field is a vector quantity. It has both magnitude and also direction. Then here already you learned Biot-Savart law. This also it is used to find out the magnetic field. Then another alternative method is Ampere's circuit law. This law is useful in symmetrical cases. This, it is applicable for only symmetrical cases. Ampere's circuit law. Suppose we have to find magnetic field due to a current I coming out of a plane of a paper at the point P. Here they are asking you have to calculate at a point P the magnetic field that is exist because the current is passing through a conducting wire. Here the current is given at the point I. Then here the current I coming out plane of a paper. The plane of a paper, it is indicated by white sheet here. Then this, consider this I as the center of the circle, and the distance between this I and P consider as R, radius of the circle. Using center I, then draw a circle of radius R. Then here you know, according to Biot-Savart law, if you want to calculate the magnetic field at a particular point P, then you have to consider a small length of the conducting wire, because if you consider the full length of the conducting wire, then you are not able to find out the magnetic field of a particular point. Then you have to consider the small length of the conducting wire. The small length we will consider as a dl here. Here also you can consider at this point anywhere on the circle you can consider the length of the conducting wire to calculate the magnetic field at a particular point P. Then here already they mention the current, it is coming out of a plane of a paper. Then this will be the direction of the current. Then according to right hand thumb rule, thumb, it will indicate the direction of the current. Then remaining fingers, it will indicate the direction of the magnetic field. Here the direction of the magnetic field, it will be in the anti-clockwise direction. This is the direction of the magnetic field. Here if you consider a small length dl, then this tangent, it will indicate the direction of the magnetic field. Here also this, it will be the direction of the magnetic field. Then here according to Biot-Savart law, you know, line integral, it will be equal to B dot dl. It will be equal to mu naught I inside. The current, it will be net current I inside. Then this line integral of B around the closed loop, because here we are considering the closed loop, because the conducting wire, it will be in the shape of a circle. Therefore line integral of B means magnetic field, it is a vector around a closed loop, because this B, it will indicate a vector because it has magnitude, and also it will show the direction. Here the direction is anti-clockwise direction. This symbol, it will indicate the closed integral. Here line integral B dot dl, it will be equal to mu naught I inside. The line integral of magnetic field along a closed path, it will be equal to mu naught times the total current enclosed by that closed path. Here the line integral of a magnetic field, otherwise magnetic field at a point P, it will be equal to mu naught times the total current enclosed in a closed path. Here one more important thing we have to learn here, sign of current. Here there are two possibility it will be there. The current it will be outside, the current it will be inside. This dot I1 it will indicate the current it is going outside. Then this into mark it will indicate the current is going inside. Then this it will depends upon the direction of the current, it will depends upon the choice of loop direction. If the loop direction, if it is clockwise or anti-clockwise, then it will decide the sign of a current. Let us discuss in detail. Then this dot or I1 it will indicate the direction of the current, it will be outward. Then according to right hand thumb rule, if the direction of the current is outward, then the magnetic field it will be in the direction of anti-clockwise direction. This is the direction of the magnetic field, otherwise this is the direction of the loop direction when the current is going outside. Then it is I1. Then if the current is going inside like I2, it is indicated by cross, otherwise it is indicated by into. Then here the direction of the magnetic field it should be in clockwise direction. Then you have to remember, if the magnetic field if it is in clockwise direction, then the current it will be going inside, it will be indicated by into mark, that is I2. Therefore sign of a current it will depends upon the choice of direction of the loop. Use Ampere's circuit law to find out magnetic field due to a long straight wire. Then here you have to calculate the magnetic field at a point P due to a current carrying in a long straight wire. You don't know the length of the wire, this is a long straight wire. Then this is the point P at a distance A from the wire. Then here consider this distance as the radius. Then construct a circle. Then here radius it will be A. Then here you know the direction of the loop, otherwise direction of the magnetic field it will be in anti-clockwise direction. Then at any point consider a small portion of the length of the wire, consider as dl at this point, and this is the direction of the magnetic field. Then here also this dl, this is the direction of the loop and direction of magnetic field in this way. Then here also this is the small portion of the elemental wire dl, and this is the direction of the magnetic field. Direction of the magnetic field and direction of the loop both also it will be same. Okay, then this is the direction of the current. Then according to a right hand thumb rule, this is the direction of the current. Then this it will show the direction of the magnetic field. Then closed integral B dot dl it will be equal to mu naught I current inside the wire. Then here in closed integral B dl, here consider cos theta, cos 0 it will be equal to mu naught I. Then magnetic field, otherwise magnetic field it will be same throughout this circle, therefore this it will be a constant, therefore take B outside. Then closed integral dl it will be equal to mu naught I. Then this dl complete closed integral dl, here we are considering small portion of the dl. If you join all the small portion of the dl, then it will become a complete circle. Complete circle is nothing but a circumference of the circle. You know the formula, circumference of the circle is 2 pi r. Here r it will be equal to a, therefore in place of r replace a. Then b it will be equal to 2 pi a, then it will be equal to mu naught I. Then here once again I will explain here, closed integral dl it will represent a full circumference of the circle. Then circumference of the circle, the formula is 2 pi r. Then here 2 pi a, then b it will be equal to mu naught I divided by 2 pi a. Here multiply and divided by 2, then 2 into 2 it will become 4 pi, then 2i divided by I, then magnetic field it will be equal to mu naught divided by 4 pi, this is a constant, then 2i divided by a. Using like this, using Ampere circuit law, you can find out the magnetic field due to a long straight wire. Thanks for listening my class. Thank you.